started the video.
Oh, now why did that happen? Did you see that? Okay. So it's going to be... Did it again, didn't it? Aha. That's so weird. 8 miles an hour. We're okay with that? Yes?
Yes.
Okay.
Yes.
So after 1 hour, what's the distance going to be?
8 miles.
8 miles. We're okay with that, right? Okay. So let's talk about speed. We just mentioned speed when we talked about 4 miles and 8 miles an hour. Right? Speed. The speed is just simply the ratio between what and what?
It's distance and time.
Distance and time, right. So it's the ratio between distance and time. And some of you guys, I think, have done this in math class before. So it's just the ratio of distance to time. And distance we measure in what?
Meters.
Meters. And time we measure in?
Hours. Seconds.
Seconds. So seconds is our base unit for time. So distance we have meters, time we have seconds, and so it's just this lovely ratio, right? Yes?
Whatever you say.
Whatever I say. So let's go back to our lovely little moving walkway, right? So if we say it's moving, instead of 4 miles per hour, 4 meters per second, that's a little faster, isn't it? Yeah. A little faster. And let's say you're walking, once again, at 4 meters per second. So, yeah. So it's going to be 8 meters per second total. You can actually add the 4 meters per second plus the 4 meters per second. You're going to get 8 meters per second. Now, you'll be adding speeds, right? So, and this 8 meters per second, that has a frame of reference. What's the frame of reference? Yes? Right. So the 8 meters per second is relative to the Earth. Yes? However, relative to the moving walkway, how fast is the person moving? Yes? 4. It's only 4 meters per second relative to the moving walkway. So you always have to do watch your frame of reference.
So like on a test you'll say, how fast is he moving?
Relative to,
Okay.
and then I'll give you something. Okay? Now there's several different kinds of speed that I want to talk about. One kind of speed is instantaneous speed. So instantaneous speed. What is instantaneous speed? It is the...
Speed at last fastest you reach.
Nope, it's not the last fastest you reach. It's not your starting speed.
It's the speed at an exact moment.
Yeah, at that moment, that instant, how fast are you going? So instantaneous speed is that exactly it. At that instant, what is your speed? Alright? So, when you're graphing motion, usually since it's a ratio of distance to time, it's always distance over time. So your distance is going to be on your y-axis, your time is going to be on your x-axis, it's going to be distance over time. So if you had a graph that looked like this, what can you say about your speed at point A versus point B? Brandon? Exactly. So notice you're not going anywhere at point B. Here you are, it's flatline. No distance over time. Time keeps marching on and you're not going anywhere. Right? You're just sitting there. So obviously you're going faster, more distance per time at point A than you are at point B. What about A versus C? What's going on there? Sokar?
Well, A's going faster, C's going quicker. So.
Right, you can see this is incline. The angle here for A is much greater than the angle at C, and so you can say, sure enough, you're going greater distance per time than you are at C. So that's good. So A, B, and C, those are all instantaneous speeds. Right? Okay. Now, between, let's number these. 1, 2, 3, 4. These points here. Between 1 and 2, And 2 and 3 and 3 and 4, you're all going a different type of speed, and that's called a constant speed. Essentially, that your distance per time unit does not change. It's always the same. Now, you're changing at point 2 and at point 3, but between 2 and 3, between 1 and 2, between 3 and 4, your speed is constant. And you can easily recognize that it's a straight line on a graph.
So if it's not constant, it'll be like what?
It would be more of a what?
It won't be moving up or down. It'll be
So if you have d over t and it's not constant, it's either going to be going up, right,
like
or
a curve.
going down. So you're going to be having a curve for not constant speed, right? So, yeah. Good. And then there's a third kind of speed. And this one is average speed. And average speed, that's where you draw that silly little line through your graph. And what's that line called?
Oh,
Yes?
average line.
The average line, or line of best fit. I think you guys have heard that before.
Yeah.
So you take a look at it, you can run the numbers, you say, okay, this is our average speed. Something like that. Actually, it'll look kind of more like that one for this one. So your line of best fit is going to be your average speed. And what it does is it takes, okay. So in case speed, did we talk about what speed is?
Yeah.
So speed is distance over time, whereas average speed is going to be total distance over total time. Right? So it's going to take all this distance and all this time that goes by, and it's going to find your average. You want to try one of those? Yeah? Okay. So let's say Mr. Schuth gets on his bike, which he actually doesn't have a bike. Yeah. Total distance over total time. Yeah. Okay.
Average speed.
So let's say Mr. Schuth, he gets in his car and he drives, he's very respectful of the speed limit, but luckily there happens to be a large speed limit on Highway 65. So he's going to go 70 miles an hour for 3 hours in his car. And he's going to do that going north. And then he's going to take a rest at the Albany's Candy Factory. And he's going to do that, I don't know, he's probably going to stay there for an hour, because that's when Santa Claus is there and they're making the gummy bears, and he's just got to see the factory and eat everything that they have, try all the samples before he buys anything. And then he's going to drive for 60 miles an hour for 2 hours south. So, let's answer a few questions. Question number 1. What's the distance that Mr. Schuth has gone? What's the displacement for Mr. Schuth? And then, what is his average speed? These are all good questions. Now, how do we answer these? Sims, how do you find distance?
You add 70 plus 60.
Add 70 plus 60. I'm sorry, I can't do that. Because 70 and 60 are both speeds.
Oh, right,
Anna?
okay.
Average weight.
2 times 60. Now,
Plus.
she's doing this without a formula. So I'm going to write the formula, and then I'll get back to you, Brandon. So the formula we talked about was speed equals distance over time. Well, Brandon wasn't interested in speed or time. She was interested in distance. So I'm going to say that distance is speed times time. Right? Now, back to you, Brandon. So distance is, how do you do that? You did 2 times 60, right? Yeah. So she said 60 miles an hour times 2 hours. right? And that's going to give me a distance of 120. 120 what? Miles. How do we know that? Hours factor out. Oops, I did that wrong, didn't I? Hours factor out there. So we got 120 miles. So this gives us 120 miles. Is that my total distance? No. What else do we need to do, Granlin?
Do the same thing
For this one? Okay, so we know the distance is speed times time. We know the speed was 70 miles per hour times 3 hours. Yes. So hours factor out. 70 times 3 is 210. Good. So 210 miles. So, does that answer our distance question? You have to add them together because this is total distance, right? So 210 plus 120 is going to give us 330? 330 miles. Now, does anyone have a question about the factoring out or the formula part?
You have to do all of that?
Yeah, I want you to do all of that. So the whole write the formula, fill it in, watch your units, and so then put a box around your answer. Okay? Now, displacement. How do we find displacement for this? Steele.
Well, in one you went north and when you went south, so you subtract 210 from negative 90.
Okay, so we went north, and then we went south, right? So we'd have to subtract 120 from 210, as she said, and what do we get? 90? So we end up going 90 miles north. So we have distance and we have direction. That is a vector, and that's displacement. So our displacement vector is 90 miles north. Now, what about...
Work for that one?
Hmm?
You just show the work for that one.
Not if it's simple like that. You know, if you end up having to do a resultant vector like the a squared, b squared, c squared, you might throw it in there. Good question. Okay, so what about average speed? That's our third question. How do we find average speed on here? Yes?
To give the speed its distance over time, so I take the...
Wait. You said speed was distance over time. Go ahead.
So you take the distance I go, which is 330 miles.
Okay, so you have to take total distance.
And you put it over 6 hours, and you try to put it down.
And over total time. 3 plus 1 plus 2 is 6 hours. So what's 330 divided by 6? 55?
Miles and
Is that right? 55 miles per hour. Now here's a question. I, Mr. Shute, never traveled less than 60 miles an hour, and yet my average speed is 55 miles an hour. Why is this true, McNulty?
Because there's the 1 hour of you not moving at all in your car.
Oh, okay. Because I was moving within the factory, but not within the car. The car was parked, waiting for my loads and loads of candy. You guys ever been to the Albanese Candy Factory?
Was
Have
it
you?
sugar-free?
There is a sugar-free section, and it's not as busy as the other section. And no, I don't like it. Ugh. Yeah, so that's essentially what we're doing here. There is one more thing that we need to talk about.